By graphing the function f of x, which is equal to the cosine of 2x minus the cosine of x divided by x squared, and zooming in towards the point where the graph crosses the y-axis, estimate the value of the limit as x approaches 0 of this function. So let's first go ahead and put this into our graph here. So we have the cosine 2x minus the cosine of x, and then we're dividing that by x squared. So this is what our graph looks like right now. Okay, and then let's zoom in a little closer here so we can see what's happening. Okay. So we can let our negative 1.4, negative 1.6, let's make this negative 1, positive 1, So what we've done is we've zoomed in a little closer. So this is what the graph looks like. And then we zoomed in closer to see where it's approaching here. So what we can say now is by looking at this graph, okay, let's first determine what's happening as the limit is approaching 0 from the left of this function. Well, as it is approaching 0 from the left, we can see that this function is approaching negative 1.5. And then as this limit is approaching 0 from the right of this function, so again, as it is approaching from the right, we can see that it's also being negative 1.5. So therefore, since these are equal, we can say the limit as x is approaching 0 of the function, the cosine of x, the cosine of 2x minus the cosine of x divided by x squared is equal to negative 1.5. Okay, now what we're going to do is we're going to check our answers in part A by evaluating f of x for those values of x that approach 0. So what we're going to do is we're going to create a table here. So what we can do is we can go ahead and copy what we have here into this and make sure that this represents x1. And then the same thing here. Just makes our computation a lot quicker. Okay, and then let's put in the values negative 0.1, negative 0.01, negative 0.001, negative 0.0001. Okay, and then we put in 0.1, 0.01, 0.001, 0.0001. So now we're going to go ahead and copy and paste those values in here. So we can see how as our values approach 0 here, from the left we get negative 1.5000, and as these values approach 0 from the right, we get negative 1.50000. So therefore, that confirms our results of what we saw in part A.